Grade 9. I'm so sorry, right? Firstly, I'm so sorry about the lecture today. This is a recorded video um, instead of our live today, our lecture. So I will start chapter 8. I start by revising what we have done in chapter 8. In the last period already I give you a brief introduction about the factoring and how we can factorize the polynomial. I see to put the importance of factorization as this small paragraph where really the factorization is very important to us, and factoring polynomials is very important to you in your age now. So, among all topics we will cover in the class, the factoring of polynomial is probably the most important topic. There are many sections later we will chapter where the first step will be factor polynomial. So if you cannot factor the polynomial, then you will not able you will not able even to start problem or finish. Good. Now, also yesterday we have talked about the factoring and the basic definition of factoring. We said that the factoring is the process to find two or more quantities whose product equal the original quantity, and when we deal with the real number like 12 here in my example, we say that 2 times 6 is a factors of 12. Negative 2 times negative 6 also is another factors of 12. These two factorizations of 12 with two factors, 12 which equal 3 times 4, also another factor. So if we take the fractions also in my consideration, there is infinitely, there is many possible factors for 12. Any number, it will be a factor for the 12. Any number, it will be a factor of the 12. So, because of that, there is what we called it by the completely factor, which is also called the prime factorization, which is we will keep continuing factoring until we reach a positive prime factor, We have defined what I mean by prime, but now I will repeat what I mean by prime number. So in my case, a prime number is a number whose only positive factor are 1 and itself. And here to be specific is an integer, not number, is an integer. The fractions is an integer whose only positive factor are 1 and itself. Good. For example, 2, 3, 5, and 7 are all examples of prime numbers. In other words, 4, 6, and 12, they are not prime numbers. We call them commutative, by the way. Okay. So if we completely factoring a number into positive prime factor, there will be a unique representation. Of course, the unique representation here depends on the order. The order is not unique, but the numbers are unique for that number. So it's a unique representation up to order. That's the reason for factoring things in this way. For example, 12, it will be 2 times 2 times 3. In other words, if I change the order of these numbers, 2 times 3 times 2, like this, nothing happened. It will be the same representation. I said it's unique up to order. The order is not important to me because the multiplication is commutative operation. Our title is factoring polynomials. Up to now we're dealing with numbers, but Factoring polynomials is done pretty much the same manner in numbers. So we will deal with polynomials like the numbers in the same manner or the same procedure. The procedure is we determine all the terms that we multiplied together to get the given polynomial or the original polynomial. We then try to factor each of these terms until finally we cannot find factors anymore, until we simply cannot find any factors. Just some examples here, and not necessary to know how we now factorize this x squared negative 16 equal to x plus 4 times x negative 4. We can factorize x squared minus 16 to be a multiple of x plus 4 and x minus 4. This is called a difference between two square formula, but this is not our lesson today. I will come to it later. But here as an example here, how we can factor, what's the meaning by factorizing polynomials. So x squared minus 16, it can be factorized to be x plus 4 and x minus 4 multiplied together. Good. This is a completely factoring. But if I give you x to the power 4 negative 16 in the same formula, difference between two squares, x squared plus 4 and x squared negative 4, it will be the factoring. But this is a factors, but not completely factoring. Why? As I said before here, I will factor firstly, then continue until simply we cannot factoring anymore. So here we will look here to factors, my factors. This is prime. This we can factorize it again. X squared minus 4, it will be x plus 2 and x minus 2 here. I'm so sorry, I'm bad. X plus 2 and x negative 2. The factoring of x squared negative 4. Good. So, our purpose to familiarize yourself with many of the technique for factoring polynomials. That's our goal, how we can factorize polynomials and how to reach fluent degree in this way. The first method to factorizing polynomial, it's the greatest common factor. By the way, I give you a feedback about the greatest common factor in the previous period, and already we have discussed how we can find the greatest common factor for the numbers, but here I will start by the definition. So the first factoring is the greatest common factor. First question I want to ask you, so how we can find the greatest common factor of two or more monomials? The steps: write the prime factorization of each coefficient in the exponent notation. That's first step. Then second step, choose the least power or the lowest power of each common prime factor that appears in all coefficients. Finally, the greatest common factor, it will be the product of these factors. For example, if we have a monomials 6a cubed c, 12a squared c squared, and negative 36a cubed c. Firstly, I need to factorize all of these monomials. 6a cubed c, it will be 2 times 3 times a cubed c. 12. This the factoring, and this is an exponent notation. I will focus on the exponent notation. This just as an explanation for you. Negative 36, it will be, because it is negative, I will put negative 1 here, first number. Then I can complete as a 36 how we can factorize it. It will be 2 times 2 times 3 times 3 which is 2 square times 3 square, a cube times c. Now in next step, I will look where is the common factor. The common factor 2 is existed in every factoring here. 2 is existed everywhere. So I will take 2 with its lowest term, lowest exponent. It will be 2, this one, this 2. I will copy it here and change the color to be this pink one. Now for A, or for 3, no, firstly, I will go for the 3. I have 3 here, I have 3 here, I have 3 here. And the lowest term is the 3. I will take this one or this one, not problem for me. So 2 times 3 up to now. These 4 numbers. For variables, for the letters here, A, we have a cube here, a square here, a cube here. So a is common, but I will take the lowest term, which is a square. In same manner, it will be the coefficient c. Here the letter c, the variable c, it will be my variable. So 2 times 3, it will be 6. 6a square c, it's my greatest common factor. What we need to find it. Already we have discussed that and take an example about this. Now, the very important thing in this lecture, how we can factorize a polynomial by using the greatest common factor. We have learned how we can find the greatest common factor, how we can find the greatest common factor for monomial or numbers. Now, how we can factorize a polynomial by using the greatest common factor. First step, we need to find the greatest common factor of each term. Then, divide the original polynomial by the greatest common factor to obtain the second factor. Of course, the second factor will be the polynomial. Will be a polynomial. Let me start to know how. But before that, I will give you this remark where you need to note that the factoring is a reverse process for multiplying. Of course, it's a reverse way. A polynomial cannot be written in the product of factors, then it's called factorable. If we can write it, then it's factorable. If not, then it's called a prime polynomial. It's called a prime polynomial. So the prime polynomial, like the prime numbers, a polynomial, we cannot factorize it at all. We cannot factorize it. Or in the same definition of prime numbers, it is factors just one and itself. Now, this example, factor each polynomial using the greatest common monomial. Let me start. If I give you this polynomial with 3 variables, x and y and z. So we need to find, first step, we need to find the greatest common factor. Let me find it. First term, term by term. The first term is 12x cubed z5. Analyze it. Rewrite 12 as it is prime factorization. It will be 2 square times 3. It's the unique representation for the 12 times x cubed z5. I will keep these already as the prime factorization. Just I need to deal with numbers. 72, it will be 9 times 8, and 9 it will be 3 square, 8 it will be 2 cube. So 3 square times 2 cube times these variables again. 60, it will be 15 times 4 or 3 times 5 times 2 square, which equal x squared to y. Finally, I will look out where is the common factors, which is 2. In my case, I will take the lowest exponent, which is 2 square. 3 also, and the lowest exponent is a 3. And just x square, which is common here for the variable, so I will put x square. I will ignore z and y because they are not existed. Here there is no z and here there is no y, so y and z, they are not common, so I will leave them. Finally, the greatest common factor, it will be 12x squared. 12x squared. As you see, this is a long procedure to find the greatest common factor. You can use the mental math. You are in grade 10 or grade 9. You can use your mental math to find the greatest common factor by its definition, which is the greatest number or the largest number which divide all terms of the polynomials. So if we get back for the polynomial here, my question, we'll find out that the 12 is the greatest common divisor of these numbers. 12 divides itself and divides 72 and divides 60, and it is the greatest common divisor or the greatest number which divides all of these terms. I advise you to use mental math. We use this method if we deal with a large number or a big number. We cannot use the mental math with it. But if you deal with numbers like 10, 12, 14, some small numbers like this, I advise you to deal with them as a mental math. So here we guarantee that 12x squared is our greatest common factor. I will take out as a first step here what I said. First step, find the GCF. We find it. Divide the original polynomial by the greatest common factor. This is the second step. So I will take it out. This is one, and start dividing. So 12 x cubed z to the power 5y divided by 12x squared. 12 over 12 it will be 1. X cubed over x squared it will be x, and z5y it will be z5y. Again, just a division of polynomial by monomial as we learned previously in chapter 7. Now 72 over 12 it will be 6, and x cubed here again we will get 5, and it will be x cubed. This is x cubed over x squared, it will be x. Now here x cubed y squared z. This is the division of the second term by our polynomial. Finally, we need to divide negative 60 over 12. It will be negative 5. And x squared with x squared cancelled, so we'll get just y. So this is the factorization of this polynomial with 3 variables. I will pick a question from Try These Questions, which is question number 8 in Try These Question, which says factorize this polynomial. Question number 8, lesson 1 in chapter 8 also. We need to factorize this polynomial. How we can factorize it? I will use mental math. The largest number divides these numbers, these coefficients, 5, 25, and 10. The largest number which divides all of them, which is 5. So 5 is the coefficient of the greatest common factor. And I will take the lowest term for the variables here, which is a squared and b. So a squared and b, this is the lowest term. So finally, we see that 5a squared b is the greatest common factor. Now we need to divide 10a cubed b cubed over this greatest common factor. We will get 1a b squared. No need to write 1, so you can remove it. 25 over 5, it will be 5. A squared with a squared cancelled. B cubed over b, it will be b squared. And finally, 5a squared b. 5a squared b is the same term. Divide them, we will get 1. Anything divided by itself, it will be 1. This, the factorization or the prime factorization of this polynomial. I hope the lesson is clear. We will continue by tomorrow or after tomorrow, inshallah. Goodbye.